Find the second derivative g double prime of x for the function g of x equals tangent squared 2x times secant squared 2x. Then evaluate g double prime of pi over 8. So g of x here is the product of two functions. I have the tangent squared of 2x times the secant squared of 2x. We will therefore make use of the product rule for the derivative. But before we work that out, let's rewrite tangent squared of 2x as tangent of 2x and then squared to remind us of how to take that derivative. And likewise with the secant squared of 2x, the secant of 2x and then squared. Our first derivative, g prime of x, will be a product rule. The derivative of the first will start with a power rule. Bring the 2 down, leave the inside alone. Subtract 1 from the power. It'll be to the first power, times the derivative of the inside, which is secant squared, leave its inside alone, 2x, now multiply by the derivative of its inside to complete the double chain rule. That's all just the derivative of the first, times the second left alone, plus the first left alone, times the derivative of the second, which is bring down the power, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside, the derivative of secant is secant tangent, leave their inside alone, it will still be a 2x, and then multiply by the derivative of that inside to complete the double chain rule there. Let's simplify the look of g prime of x before we try to take the second derivative. The first term we have a 2 and a 2, we can multiply those together, that's a 4. We have a tangent to the first power. We have a secant squared and another secant squared, and that'll be secant. You add the exponents to the fourth. Plus the next term, we have a 2 and another 2. We can multiply those. That's a 4. We have a tangent squared and a tangent. Add those exponents, that'll be tangent cubed. So tangent of 2x cubed. And then we have a secant and another secant, and that will be secant squared. Each of these terms are then a product of functions, so each term will require a product rule for the second derivative. So the second derivative, g double prime of x, will be the derivative of the first. The derivative of tangent is secant squared. Leave the inside alone and then multiply by the derivative of the inside to complete the chain rule, and that will be times the second left alone plus the first left alone times the derivative of the second, which is starting with a power rule, bring down the power, leave its inside alone, subtract 1 from the power, times the derivative of the inside, the derivative of secant is secant tangent, leave the inside alone, and then multiply by the derivative of the inside to complete the chain rule. It's a double chain rule once again. Plus, the next term in g prime of x is also a product, and we will make use of the product rule. The derivative of the first, bring the 3 down, it will multiply with the 4 to give us a 12. Leave the inside alone, tangent of 2x to the subtract 1 from the power. Multiply by the derivative of the inside, the derivative of tangent is secant squared, leave its inside alone, and then multiply by the derivative of its inside to complete the double chain rule. That's all the derivative of the first, times the second left alone, plus the first left alone, times the derivative of the second. Start with the power, bring the power down, leave the inside alone, subtract 1 from the power. So now be to the first power. Multiply by the derivative of the inside, which will be a secant 2x and a tangent 2x. And then leave that inside alone, which is 2x, and then times the derivative of that inside to complete the double chain rule. That'll give us a 2. So there's our second derivative, g double prime of x. It's pretty long right now, but we can simplify the look of this, and there may be some terms that will combine. The first term, we have a 4 and a 2. That will give us an 8. And we have a secant squared and a secant to the 4th. That will give us secant to the 6th. I'm now going to write it as secant to the sixth of 2x because we no longer need to take any more derivatives. The next term, we have a 4, a 4, and a 2. 4 times 4 is 16 times 2 is a 32. So plus a 32. We have a tangent and another tangent, so tangent squared of 2x. We have a secant cubed and a secant, so secant to the fourth of 2x. The third term, we have a 12 and a 2. That'll be a 24. We have a tangent squared of 2x. And we have a secant squared and another secant squared. That'll be secant to the fourth of 2x. In the last term, we have a 4 times a 2 times a 2. That will be a 16. We have a tangent cubed and one more tangent, giving us tangent to the fourth of 2x. And we have a secant and another secant, secant squared of 2x. Now the middle terms can actually combine together. These two terms have the same form other than differing coefficients, but they're both tangent squared and secant to the fourth. So we can add those together. So our g double prime of x will be 8 secant to the sixth of 2x plus 56 tangent squared 2x secant to the fourth 2x, and then we have the 16 tangent to the fourth 2x secant squared 2x. This is somewhat factorable here. Looks like we have a common factor of an 8 that can factor out. So we'll have 8 times, and that'll leave behind secant to the sixth of 2x, and the 56 divided by 8 will be a 7. Tangent squared 2x secant to the fourth of 2x plus 2 tangent to the fourth of 2x secant squared of 2x. We can now factor out powers of trig functions. It looks like the only one that can factor is a secant because the first term does not have any tangents. So in our first term we have a secant to the sixth, our second term we have a secant to the fourth, and our third term we have a secant to the 2. We can factor out the lowest of the 3, which is the 2 power. So g double prime of x will be 8 secant squared of 2x times, and when you factor, you're dividing, and dividing means subtracting exponents. So if we take out 2 secants, we'll be left with the first term having 4 of them. The second term having 4 to begin with, 2 taken away, we'll have 2 left over. So secant squared of 2x. And then the third term, we're taking away 2 of them, and it has only 2 to begin with, so both of them will get taken away. And we'll be left with just that tangent to the fourth of 2x. So there's the factored version of the second derivative, g double prime of x. The next thing to do is to evaluate g double prime of pi over 8. And that will give us 8 times, now remember secant squared means the secant first, and then square it. Likewise, the secant to the fourth means the secant first, and then raise it to the fourth, plus 7 times the tangent squared, which means tangent first, then squared, secant first, and then square, plus, and then 2 times tangent to the fourth means the tangent first, and then to the fourth. Well, 2 pi over 8 can reduce, and it reduces to pi over 4. So we have 8 times the secant of pi over 4 squared, and then the secant of pi over 4 to the fourth, plus 7 times the tangent of pi over 4 squared, times the secant of pi over 4 squared, plus 2 times the tangent of pi over 4 to the fourth. So we have 8 times. Now the secant of pi over 4 is 1 over the cosine, the reciprocal of cosine. Cosine of pi over 4 is root 2 over 2. The secant will be the reciprocal of that, and that will be 2 over root 2. And we have that squared. And here we will have a 2 over root 2 to the fourth, plus 7 times the tangent of pi over 4 is sine over cosine, and sine and cosine match at pi over 4. They're both root 2 over 2. Sine over cosine would be a 1. Tangent of pi over 4 is a 1. The secant, again, is 2 over root 2, and we have that squared. And then we have the final term, which is the tangent of pi over 4, which is a 1 to the fourth. So this will be 8 times 2 over root 2 squared. You can square each of them. 2 squared is a 4. Root 2 squared is a 2. And this is multiplied with 2 to the fourth. 2 times 2 times 2 times 1 more 2 will be a 16. Root 2 to the fourth. Root 2 times root 2 is 2. Times another root 2 times another root 2 will be another 2, and that will come out to a 4. Plus 7 times 1 squared, which is a 1, times a 2 squared, which is a 4, over a root 2 squared, which is a 2, plus 2 times 1 to the fourth, and 1 to the fourth is a 1. Well, 4 over 2 is a 2, so I'll write it that way. 16 over 4 is a 4, plus 7 times 1, which is a 7. 4 over 2 is a 2, plus 2 times 1, which is a 2. 8 times 2 is a 16. And we have that multiplying 4 plus 7 times 2, which is a 14, plus 2. And we have 4 plus 14, which is an 18, plus a 2, which is a 20. And 16 times 20 comes out to 320.